to do next is talk about changes in state functions yet again, and we're going to relate it to something that's extremely valuable called heat capacities. Heat capacities are great because all you have to do is look at a change in temperature and you get the heat exchange. It's really cool. However, with our different assumptions that we make, if we want to have constant pressure, constant volume, yada yada, things are going to change. So, let's first consider some changes in state functions. Okay, for an ideal gas, internal energy and enthalpy depend on what properties? Yep, P. What else? P, V. Yep. Yeah. It's a question. How many independent variables? Are there for an ideal gas? Assuming moles are constant. So moles are constant in this case. We're not going to worry about changing moles, in fact, for a while, for the remainder of the semester, probably closer to the end. So if we want to know pressure, what do we got to know?
Volume and temperature.
Yep, volume and temperature. If we want to know volume, what do we got to know? Pressure and temperature. So right now, with our conditions of constant moles, what things do we got to keep track of? How many independent variables do we have? We technically have 3, but we're going to ditch that n. So we got 2, right? 2 independent. Okay. We could pick any combination we want to express U and H. We're going to pick ones that make math easier. You can prove it to yourself later on that it in fact is easier, but we're going to pick some easy ones. So we're going to say U depends on temperature and volume, and H depends on pressure and temperature, and there's a reason for that. Do we have to say this? What else could U be a function of? Yep, could be P. So it could be P and T or P and V. What about for enthalpy? What other ways could we express this? Yeah, volume, toss it in there. We're picking the easier ones. On a Quizlet question, you'll probably, not this next one, but later on, you'll prove that it is in fact easy. Okay, so let's say you wanted to look at the change of U that depends on temperature and volume. We can split this up into 2 terms. One where we're changing what? Yep, and one where we're changing. Yep. What's this differential going to look like? Change in U over change in what? Sure. Keeping what constant? Yep. Times what else? Yep. What about the second portion of this? Yep. Okay, now if we look at the change in H, which we defined as function of pressure and temperature. What's that differential going to look like?
Partial of H
Yep,
over partial of D.
yep, keeping what constant?
Temperature.
Times, yep, plus,
Partial of H
yep,
over partial of temperature
uh-huh,
over pressure constant times T.
exactly. Should be able to do that pretty fluidly, looking at any expression that we want to consider. Next time, what we're going to do, we're going to look at these expressions, and we're going to find two different types of heat capacities. One at constant volume, and one at constant pressure. And it's going to make your lives tremendously easier in the future to see when you can utilize those heat capacities. The beauty is, eventually, like for example, delta U, you can do this. That's what we're going to talk about next time. Okay. Are there any questions right now? Okay. Lab reports, just get them to me when you can. Turn them in online if you can too. This week we're going to be meeting for pre and post. So if you want to meet with me, just let me know. I don't have to go anywhere. I don't have to drive to Buffalo at all this week, so I will be here till like 4 today, 5 every other day. Okay? All right, have a good day, guys. Take your cupcake with you if you want another one.